Hollis Prism Explorer. It was developed by Kevin Gurr, and it's going to be manufactured and distributed by Hollis. For this rebreather, to meet the PADI recreational specification, we needed to have a bailout valve, so we've designed this bailout valve. All of the connections are screw-on. You should not use quick disconnects in the life support system. It has 3 positions. This is closed circuit, and that is open circuit. When it hasn't been broken by the show monkeys, it will be stopped by a cam when you raise it back up in closed circuit, and to get to the closed position, you pull it up and take it all the way back. Very low resistive effort, very good worker breathing on the second stage. This is the primary display for the Explorer. It is normally green. When it's green, it means go, play, have fun, be a fish. If it goes green, blue, it says, look at my handset, I have a message for you, which might be, you might want to go to a shallower depth. And when it goes red, there's a single response, pull the lever down, go to the boat. So the rig is designed to be very, very simple, using very, very complex technologies. This is in the jacket configuration. We also make it with a wing. We have weight pockets in the jacket configuration. It is a single gas rebreather. It uses nitrox 40%, likes nitrox 40, works at 36, works at 32. We transmit high pressure to the handset. This unit is where all of the magic happens. The exhaled gas comes back into the rebreather, and where it enters the rebreather, there's a valve. And if the valve is closed, you cannot breathe on the loop. If a scrubber is present, the valve is open and you can breathe on the loop. And when the loop is open, you'll see this green indicator. No green indicator, no scrubber. Green indicator, scrubber. It's a pre-packed cartridge of loose media. Over here is the electronics head. When you remove this, you'll see the charge and download port. This and the handset and the HUD go back to the room with you. There's another module inside that's easily removed that contains the sensors, 3 oxygen sensor, 1 CO2 sensor, and a thermal probe that goes up the center of the scrubber. We're looking at CO2 3 different ways. We calculate the amount of CO2 created by the amount of oxygen that's been consumed. We measure it looking at the thermal stick where we see the burn, and we have a gaseous CO2 sensor that will see CO2 if it ever gets through the scrubber. This is designed for 2 hours of use. It's a 3.8 liter Luxfer up to a 5 liter Beaver cylinder. What does it do that's different? What does it do that's special? It modifies the PPO2 during the dive to extend your range, either your range of no deco time or your range of gas duration. So if you have a 36% that is set for 100-foot MOD, maximum operating depth, where you'll hit 1.6, but you don't really want to hang out at 1.6, you tell the unit no higher than 1.4. You dive down to 100 feet. If you want a little fast, you actually get over 1.4, the unit will wait for you to breathe the rig down to 1.4, and then it will inject gas to maintain 1.4, because it knows a high PPO2 means reduced inert gas exposure, longer bottom time. Then if you come back up to a 40 or 30 foot range of the dive, where you normally will have a very long no-D time, the rig will go, oh, I don't need to give you this guy all that much oxygen, so it'll tap the oxygen down. And you can tell it to go as low as 0.3 ppO or 0.4 ppO or 0.5 ppO. And it does that to extend the range of the gas. 2 hours, 2 1-hour dives, 1 nice long 2-hour soak. We had a meeting at last DEMA, and PADI came in and put on a close to a 2-hour presentation on what they thought the future of rebreathers are going to be. And they said that they saw rebreathers following the same trajectory that nitrox followed. Technology, training, and travel made nitrox a mainstream gas, where there are people today who exclusively dive on nitrox. And they see the same thing happening with rebreathers. As a real manufacturer, we're able to manufacture lots and lots of components. So we're going to work with resorts. We're going to qualify them as either an Explorer resort or a Prism resort, and we'll require that they have a service technician on staff. They have components to do repairs on hand. They have scrubber on hand. They have gases on hand, and they have the frame and the BC on hand. So you'll be able to take the back plate off, pull the electronics module out, take the breathing loop, wrap it up, put it in the overhead, fly to the resort where you've reserved the other components along with your room, build your rebreather up the day you get there in about 10 minutes, and have it ready for you to dive the next morning. This is the Hollis Prism 2. It's based on Peter Reedy's Prism Topaz. We acquired the Prism Topaz in 2007, and we've worked very, very hard to retain the performance of the Prism, which is an exceptional rig, while moving it into modern manufacturing so that parts are interchangeable and spares are readily available. We have a standard bailout valve on this rig that has a closed and open like everybody else, but you can mount our BOV on this rig. In the closed position, there's a water purge hole. The barrel is 3/16 stainless, and these two nuts are nickel-plated brass. And the reason why we do this is to make the mouthpiece heavy while the hoses are buoyant. On the exhale into counterlung, we have an oxygen add button. Oxygen should be added to the gas that you've exhaled, not the stuff you're about to inhale. This is really important at depth. This is a very simple button to work. We can pull some of this off and let you look at the inside of it. There's just a circlip. You pull the circlip off, spring comes out, button comes out, they're 2 O-rings. Not much to it. This is a Cytec overpressure valve. Something that's interesting about the way we make our counterlungs is that the breathing hose and the counterlung hose are not connected. And there's a real important reason why this is the way it is. This is a water trap. If you're getting water in your mouthpiece, you don't want water in your scrubber. So the water ends up draining into the counterlung. Water can come from poor mouthpiece management, you're drooling over a mermaid, or you've left the mouthpiece open and oops, some got in there. So each counterlung has a drain, and this is a common user interface. This is the inflator off of a safety vest. You just unlock it, fill the buoyancy, fill the counterlungs up, and then pull back and squeeze, and you can squirt the water out of the counterlung. It may take a couple of shots to get it all out, but they're very easy to drain. Over on the inhale side, we have already disconnected our demand addition valve. This is a very simple valve. This plunger activates a Schrader valve, and when it's in place on the counterlung, if you bottom the rig out, you empty the compliant volume by inhaling, it will bottom out and add gas. If you tap it, it will hit the back of the counterlung and it will add gas. The connections, valve mounting, everything in the diver shutoff valve is one way. You cannot assemble this back. You can maybe get one part in and then nothing else is going to fit and you'll know that you've done something wrong. Up here on the nipple end of this elbow are 6 flats, and on the threaded receptacle we have 6 flats. So this hose fits at a 45-degree angle into this fitting, and this hose fits at a 45-degree angle into this fitting. This hose has 4 flats, 6 flats. Our little covers aren't quite working yet, but what we're using to hold the hoses on are called Oedeker clamps. They're usually used in aviation. You quite often see them holding the hose on an oxygen mask in a fighter. We'll be putting 2 of these on each hose end. And you can use a pair of needle nose pliers and pinch the mechanism, cause it to open. There's a special tool that the service facility might want to have. We have a D-ring mounted low for sling tanks. Okay, so that's kind of the front end of it, pressure gauges. This is how the pressure gauges hang with a standard tech plate configuration. With a standard configuration, they come out of the side and you've got a little more length on it. We will make longer high pressure hoses available if people want them. Counterlungs are held down by this strap, connected to the crotch strap so they don't float up. They're held close to your chest by this strap. The rig can accommodate 30s, 19s, 12s, and 13s. This is a bump cover. That's all it's there for. Overhead environment protection of the electronics. Easy to take off. High impact ABS plastic. So this is what we call the Prism core. And the core's main components are the scrubber head, and the electronics housing and battery compartment. So starting from the top, We have a roll bar to protect it. The battery compartment and electronics housing are the only gas spaces in the rig. And these are designed to withstand pressure at 200 meters. We just finished doing an FEA analysis, and we found at a depth of 1,795 feet, it begins to see the pressure. So we've got a solid 3-to-1 safety factor at 200 meters. These are Nielsen Sessions locking latches. There is a little die here that you got to flip to get them open. So they're a little better than non-locking. Inside here we've got 2 batteries. We've got a pair of 9-volt alkalines, and the 9-volt alkalines will drive the solenoid for 45 hours, just straight firing every 5 seconds, and a 3.6-volt lithium-ion battery that will drive the LED primary for 200 hours. In the electronics compartment, all of the penetrators are protected with 2 O-rings. We have a face seal and a radial seal. And we have a port here we're not using and a port here we're not using, so we're ready to plug in additional sensors or additional displays. The way things come into the compartment, there are a bundle of wires. We use Molex high pressure terminals on the ends of the wires. Unlike most Molex terminals, instead of being a little finger that touches one side of the pen, the Molex high pressure terminals are little boxes with bent in sides, and they grip the pin all the way around. The wiring harness for the batteries is mounted to a Molex receptacle. You can unplug it if it becomes corroded, plug a new one in. We've done the same thing inside the breathing loop where the 3 oxygen sensors are located. And the 3 oxygen sensors, we're also using a copper stranded wire that each strand of copper is coated with silver. It's the most corrosion resistant stuff we can find. Gold-plated terminals throughout. The buckles that hold the bucket on are locking Nielsen Sessions latches, the same as we use on the battery compartment. The O-rings are metric standard 175 times 3.5. The basket is made out of glass-filled ABS and nylon screen. It's very insulative. The scrubber material likes to be warm, so we work to give it a nice warm environment to work in. That's much more efficient use. It is a radial scrubber, so we have very low resistive effort. I told our technical writer, hey, you could stand on it, don't worry about it. So he sends me a picture of his 140-pound girlfriend standing on the scrubber. And I said, no, I need the lighting a little bit different. So Jenny off and on several times, and it didn't bother it at all. Very easy to take apart, very easy to clean. The nylon protects the scrubber material. If you're vibrating in a boat or in a car, you're not going to be using the perforated steel outer wall as a cheese grater, dusting your absorbent. This clear bucket, it's kind of cool to have a clear bucket. And some of the things that happen when you got a clear one instead of one that's not clear is you can see if the scrubber's in there. You can see if the scrubber's full in there, and you can see if there's any water in there. ShamWow, works great. For electronics, we are using, we call it the secondary because we learned how to build these with the military. The secondary display is Bruce's Predator. It does everything for you but cook toast. It is a stunning product. If you ever need to bail out to open circuit, you can bail out to open circuit with this rig. We also use Shearwater HUD, and the HUD and the Predator share the millivolt connection from the oxygen sensors. There's no signal conditioning before the millivolt signal goes to the 2 devices. So on this device, we have 3 LEDs, and they flash in a code that tells you what your PPO2 is, and they match up with the 3, obviously we need to calibrate this, but the 3 locations for digital PPO2 layout. So this is number 1, number 1, number 2, number 2, number 3, number 3, and they clock that way inside of the scrubber head for diagnostics. If you go and sever this cable, you can continue to fly the rig on the PPO2 information that's provided by the heads-up display. That's something the original Prism did, and we thought that was the most important safety feature for us to retain.